Hello everyone, welcome to another video of PyNet Labs. My name is Chirag and I'm here to provide this video as a solution video of assignment number 8. So this assignment was a part of $100 giveaway. If you do want to participate in such giveaways, you can join the Telegram group of PyNet Labs from the link given in the description. So let's get started. Let's quickly see what do we have in this assignment to do. So this is our assignment number 8. It asks you to design the topology like shown here and then change the host name to PyNet 1, PyNet 2, PyNet 3. Then it asks you to configure IP addresses and DHCP pools. After that, make the VLAN configurations and it asks you to put inter-VLAN routing using router on a stick method. And lastly, it asks you to configure EIGRP for making all the networks communicate. So let's quickly get started. Let's begin the configurations. I have a similar type of topology ready with me. I'll quickly open that and then we'll begin the configurations on this topology, which is shown here. So this is the topology. We have all the three routers. Let's begin the configuration from PyNet 1. So I'll click on this PyNet 1 CLI and we'll start putting the IP configurations. So I'll say enable config T. Let me change the host name to PyNet 1 and then on interface FA0/1, which is this interface. I'll just enable the names. This is FA01. On FA01, I'll be providing IP address from the subnet 192.168.9.0/30. So IP address 192.168.9.1 255.255.255.252. No shutdown. Exit. And after that, we have to configure some sub interfaces for FA00. So I'll say interface FA0/0 and no shutdown.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Then I'll go inside interface FA00.10, which is a sub interface. We'll encapsulate it with the VLAN number 10. So encapsulation.1q10, and we'll provide it IP address 192.168.1.1 255.255.255.224 as /27 is supposed to be used. And say exit. Similarly, I'll put configurations on another two sub interfaces. So interface FA00.20, encapsulation.1q20, IP address 192.168.2.1 255.255.255.224. Exit. Then interface FA00.30, encapsulation.1q30, IP address 192.168.3.1 255.255.255.192 because /26 is the subnet which we have to use. So exit. After configuring the IP address, I'll move to router number 2 and we'll put the IP addresses there. Enable config T host name at PyNet 2. On interface FA0/0, we'll put the IP address 192.168.9.2 255.255.255.252. No shutdown. Interface FA1/0, no shutdown. Then we'll start configuring the sub interfaces. Interface FA1/0.10, we'll say encapsulation.1q10, and IP address will be 192.168.4.1 255.255.255.192. Exit. Then interface FA1/0.30, because we have VLAN 10 and VLAN 30 here. So we .30 encapsulation.1q30, IP address 192.168.5.1 255.255.255.0. No shutdown. Take an exit. Then put the IP on FA0/1. So interface FA0/1, IP address will be provided from the subnet 9.4/30. So IP address 192.168.9.5 255.255.255.252 and no shutdown. Exit. Then we will move to router number 3 and we'll put the IP configurations there. Inside the CLI, I'll say enable config T host name PyNet 3, interface FA0/0, IP address 192.168.9.6 255.255.255.252 and no shutdown. Then interface FA0/1, no shutdown. Interface FA0/1.10, encapsulation.1Q10, IP address 192.168.6.1.255.255.255.0. Exit. Then interface FA0/1.20, encapsulation.1Q20, IP address 192.168.7.1, 255.255.255.192. Take an exit. Then interface FA1/0/1.30, encapsulation.1Q30, IP address will be 192.168.8.1, 255.255.255.128, and say no shutdown. Exit. We are done configuring the sub interfaces as well as the physical interfaces. Now it's time to put the DHCP configurations. So I'll go to PyNet 1, we'll start putting the DHCP configurations. IP DHCP pool A for the network 192.168.1.0, 255.255.255.224, and the gateway address will be 192.168.1.1. Exit. Then I'll create two more pools for the rest of the two networks. IP DHCP pool B for the network 192.168.2.0, 255.255.255.224, and the default router address will be 192.168.2.1. Exit. Then IP DHCP pool C for the network 192.168.3.0, 255.255.255.192. Exit. Okay, we also have to define the default router address here. So default router 192.168.3.1, and then exit. Now we will basically assign the IP address to the PCs. So it's not gonna work because all the PCs are currently in VLAN number 1 and they are not yet associated with their respective sub interfaces which we have configured on the router. So I'll go to the switch and we'll put the configurations there for all the VLANs. So say enable config T VLAN 10, VLAN 20, VLAN 20, VLAN 30. Exit. Do show VLAN brief. We have all the VLANs. Now it's time to make the interfaces participate into their respective VLANs. I'll select the range, interface range FA0/2 to 3, and we'll say switch port access VLAN 10. Say exit. Interface range FA0/4 to 5. These are going to be a part of VLAN 20. So switch port access VLAN 20. Exit. Interface range FA0/6 to 7. These are going to be a part of VLAN 30. There. Exit. Then interface FA0/1 will be converted into a trunk port. So switch port mode trunk, so that it can communicate with all the VLANs. Or we can say it can carry the communication coming from all the VLANs to the router. After this point, these devices should be able to get IP address. So if I go now and say DHCP, it is working fine. Similarly, if I go to PC2, desktop IP DHCP, we are receiving the IP address. So I'll follow the same process here on router number 2 also. We have the, first of all, IP configurations here only. So I'll create DHCP pools, IP DHCP pool A for the network 192.168.4.0, 255.255.255.192 with the default router address as 192.168.4.1. And we'll say exit. Then IP DHCP pool B for the network 192.168.5.0, 255.255.255.0, and the default router address as 192.168.5.1. Exit. Now after this point, I'll go to the switch. We'll put the VLAN configurations there. Say enable config T VLAN 10, VLAN 30. Because there is no VLAN 20, we are not gonna configure that here. Then after that, interface range FA0/2 to 3, inside switch port access VLAN 10. Then select the next range, interface range FA0/4 to 5, switch port access VLAN 30. Exit. Then After this, we will convert FA01 into a trunk port. So switch port, mode, trunk, end. And now if I go to PC6 and try assigning it IP address, okay, the port is still booting up. Let's wait for it. Or we can just skip the time using this option given in the packet tracer. I'll try it again. There you go. DHCP request successful. We got the IP address. Similarly, I'll assign the IP to PC8 also. There you go. Now we will create the DHCP pools for PyNet 3. So IP DHCP pool A for the network 192.168.6.0, 255.255.255.0 with the default router address 192.168.6.1. Exit. Then IP DHCP pool B for the network 192.168.7.0 with a subnet mask 255.255.255.192 and the gateway address as 192.168.7.1. Exit. Then finally IP DHCP pool C for the network 192.168.8.0, 255.255.255.128 and the default router address will be 192.168.8.1. Exit. Now it's time to configure VLANs on the switch. There, I'll say enable config T VLAN 10, VLAN 20, VLAN 30. Exit. Interface range FA0/2 to 3. Switch port access VLAN 10. Then interface range FA0/4 to 5. Switch port access VLAN 20. And interface range FA0/6 to 7. Switch port access VLAN 30. Exit. So we have the VLAN configurations. We will also put interface FA01 as the trunk link. So switch port, mode, trunk, end. After this, the PCs should be able to get the IP address from the router. Desktop IP DHCP. There you go. Desktop IP DHCP. Okay. So we have all the devices configured with the IP addresses, and if I try making the communication from this PC to, let's say, this PC, I think I haven't assigned the IP here. So if I try from PC1 to PC2, which are in different VLANs, it is getting successful, right? Because we have already configured router on a stick. I'll also assign the IP here on PC5 there. Now, the assignment also asks you to put EIGRP configuration so that the PC0 can also communicate with the PC6, which is connected with a different router. This communication will only be possible if there is some routing configured between these devices. So we'll be putting EIGRP configurations here. I'll say router EIGRP 10, no auto summary. I'll advertise the network, first of all 192.168.9.0 with the wildcard mask 0.0.0.3. Then I'll advertise network 192.168.1.0 with a wildcard mask 0.0.0.31. Then network 192.168.2.0 with the same 0.0.0.31 wildcard mask, and network 192.168.3.0 with a wildcard mask of 0.0.0. It should be 63. Yeah. Exit. Then I'll go to this router number 2. We'll put the EIGRP configurations there. Router EIGRP 10, no auto summary, network 192.168.4.0 with a wildcard mask 0.0.0.63. Then network 192.168.5.0 with a wildcard mask 0.0.0.255. Network 192.168.9.0 0.0.0.3 as the wildcard mask. The neighborship came up. Then we will also advertise this particular network. So I'll say network 192.168.9.4 with the 0.0.0.3 wildcard mask. Exit. Similarly, I'll go to the last router and we'll put the EIGRP configurations here. Router EIGRP 10, no auto summary, network 192.168.9.4, 0.0.0.3. The neighborship came up. Then after that, we will advertise network 192.168.6.0 with 0.0.0.255 as the wildcard mask. Then network 192.168.7.0, 0.0.0.9.0 the wildcard mask should be inverse of the subnet mask, and the subnet mask here is 255.255.255.192. So the wildcard mask will be 00063. Similarly, network 192.168.8.0, the wildcard mask here will be 000.127 and exit. Now, after advertising all the networks, if I go to this PyNet 1 and say end show IP route to check the routing table. So we definitely have multiple EIGRP learned routes, right? We have all the routes here. We have for 9.0, we have for 9.4, we have for 8.0/25, we have for 7.0 with /26, then 6.0 with /24, then we also have for 5.0, 4.0. So basically all the routes are successfully installed into the routing table of R1. Similarly, you will find the same on R2 and R3. Now, after this point, these routers should be able to route packets to their respective networks. So if I try this communication again now, it should get successful. There you go. PC0 is able to communicate with PC6. Similarly, if I try communication with, let's say, PC5 and PC12, first packet failed, then there you go, it is getting successful. We can try to ping all the end devices from any of the end devices. It will definitely work because their gateways are aware of all these networks now because of EIGRP configuration. Now, if we look back to our assignment and try to check whether we are done with all the tasks, then the very first task was to change the host name, which we have done correctly. Then task number 2 was about assigning IP addresses and DHCP pools, which also is correctly configured. Then the last task number 3 is to configure the devices inside VLANs, which is again correctly done. Then inter-VLAN communication is also working and EIGRP is also working. So we can assume that we have successfully completed the assignment number 8 and we can submit it. I hope you guys enjoyed the video and got to learn out of it. Make sure you try practicing out these topologies, and I'll see you in some other video. Till then, take care. Bye bye. Thank you so much for joining in.